Hello students. Today's video we are going to talk about the dual of an LPP. That's the linear programming problem. Now, when I talk about the dual of a LPP, first and foremost, we need to understand that the question given to us is called the primal. Okay. The question originally which is given is called the primal. And when you change it, it becomes a dual. Okay. It's something in the lines of the dual in logic and set theory. Fine. So why do we require dual? Is because sometimes the primal is very complex and not so easy to solve. So those complex problems can be converted into dual, and there's a theorem which says the optimal value of both will be the same. Okay, so if you get a optimal value optimization answer from dual, it will match with the optimization answer of the primal. So it works. Okay. So let's understand few conditions before we start with the question on changing the primal to dual. So in this category of questions, your question will be divided into two types. One is maximize and minimize. Now, if you remember, simplex method, all your questions will only maximize. Okay. Here we are allowed to have both maximize as well as minimize. Okay. That is first thing you need to keep in mind. Second thing, all the constraints of maximize will be less than or equal to, and all constraints of minimize will be greater than or equal to, compulsory. So if there is a constraint which is not so, if not, you will have to multiply by -1 and change the sign of the constraint. Okay. And same thing here with respect to the constraint, not with respect to the optimization. The optimization will remain the same. Okay. So when it's maximized, you use, or your question should be less than or equal to. If it's minimized, your question should be in the form of greater than or equal to. Okay. So that's the thing with respect to the primal. This is how the question should be given to you. Now let's understand how to calculate the dual with the help of an example. The question goes like this. Write the dual of the following LPP. Now this question in the university papers is expected for somewhere around 5 marks. Okay, not very often seen, but yes, it is seen in the paper. So either this question or the basic solution questions, they come for 5 marks. Okay, so you should be able to attempt these questions. Let's look at one of these questions first. The question is to maximize z, which is equal to 2x1 minus x2 plus 4x3, subject to the conditions x1 plus 2x2 negative x3 less than or equal to 5. Then we have 2x1 negative x2 plus x3 is less than or equal to 6. Then we have x1 plus x2 plus, okay, let me write it properly, 3x3. And lastly, we have 4x1 plus x3 is less than or equal to 12. And we have x1, x2, x3 all greater than or equal to 0. So this is your question. The question is to find the dual of this particular LPP. Observe the LPP is in the form of maximization. If the LPP is in the form of maximization, as per your required condition, all your constraints should be less than or equal to. So the constraints are already less than or equal to. Hence, we do not touch the question. We'll directly move to the finding of the dual. Also, before that, there's one thing which is missing. There's a x2 term which is missing. So I'll put here 0x2, okay, which doesn't change the equation at all. Just that I've introduced a 0x2. Now we need to understand there are four constraints. Constraint number 1, 2, 3, and 4. So the dual will have four variables. You need to understand what happens in the dual is the constraints give you the variables and the variables give you the constraints. Okay, it's the other way around. So if I talk about this, because the primal or the original question has four constraints, I'll have four variables in the dual. Okay, so this side we're talking about the dual and this side we're talking about the primal. And Here, because I have three variables, I'll have three constraints in the dual. Okay, so that's how the calculation works. So let's look at the dual of this particular problem. Now, to begin with the dual, the maximization question, the dual will become minimization. Okay, so I'll have to minimize another variable, say w, not z. I'll minimize w equal to 5y1, 6y2, 10y3, and 12y4. Now, where did I get these variables from? Let's understand each of the constraint 5y1, 6y2, 10y3, and 12y4. These are your coefficients 5, 6, 10, and 12. Okay. Now we go to the constraints. So the constraints come from the coefficients of x1, first constraint, coefficient of x2, the second constraint, coefficient of x3, the third constraint. So if I look at the coefficients of x1 in all the four constraints above, I have one x1 in the first one, so I'll have a y1, and then I'll have a 2y2, then I'll have a y3, and I'll have a 4y4. And because it's minimization, it's going to become greater than or equal to, and that will be 2. Where did I get these values from? 1, 2, 1, 4. So 1, 2, 1, 4. Of course, the ones are not written. And the 2 comes from here. 2 comes from here. Okay, I hope that's clear. Constraint number 2 is going to come from x2 everywhere. So for x2, 2y1, negative y2, positive y3, and a 0 y4. Greater than or equal to, again, the coefficient of x2 from the objective function, that's negative 1. I'll again highlight and show you the coefficients 2, negative 1, positive 1, 0, and less than or equal to negative 1. Again, 2, negative 1, positive 1, 0, and greater than or equal to negative 1. Now we'll just quickly write down the last one. That's going to come from x3. That's negative y1, positive y2, plus 3y3, and y4 greater than or equal to 4. I hope I don't need to show you where these have come from. Okay. And lastly, we'll just mention y1, y2, y3, and y4 all to be greater than or equal to 0. This is your required dual. This is your required dual for the given primal. Okay. I hope the first question is very clear, and you need to understand such simple questions do not come directly for 5 marks. So when the question is going to come for 5 marks, there'll be more complexities in the question. So I'll take 2, 3 more questions to get you used to more complexities here. Okay. This was a basic, very simple question. I hope the concept is clear with everyone. Let's move further to the more complex questions where there'll be more changes to be done. Okay. So the main question remains the same. We are supposed to find the dual. Now this time we are supposed the question the primal is minimized. So that is equal to x2 plus 3x3 subject to 2x1 plus x2 less than or equal to 3, x1 plus 2x2 plus 6x3 is less than or equal to, sorry, is greater than or equal to 5. And lastly, negative x1 plus x2 plus 2x3 is equal to 2. And we have the given condition again x1, x2, x3, all three are greater than or equal to 0. Now let's observe the question is of minimization category. For minimization question, all your constraints should have been greater than or equal to type. Now observe there's only one equation which is greater than or equal to type. All the remaining two are not in the greater than or equal to form. This one which is less than or equal to we are going to deal with by multiplying by negative 1. Now this equal to, if you remember, we had discussed this before as well, that the equal to should be split into both less than or equal to and greater than or equal to. So my step 1, I will have to go for the standard form first. So we write down the standard form as minimize 0x1, x2, and 3x3. I've just written a 0x1 there. Then we go to subject to Now the first constraint, I need to multiply by -1 just to convert the less than or equal to 2 into greater than or equal to. So -2x1, -x2 plus 0x3 becomes greater than or equal to -3. Okay. Constraint number 2, no changes because it is already greater than or equal to. Constraint number 3 will be split into two parts, -x1, +x2 plus 2x3 greater than or equal to 2. And we'll have a less than or equal to for the same, but that less than or equal to I'll multiply throughout by negative. So I'll get x1, -x2, -2, x3 greater than or equal to -2. I'll tell you this was previously this one. Okay, which we have multiplied throughout by -1 to remove the less than or equal to constraint, and this is what we got. Okay, and we still have x1, x2, x3 as greater than or equal to 0. I hope things are clear. I'm going to erase this one from here. Okay, now once you get it till here, let's understand. We are now ready to find the dual. This was your standard form. This was your standard form. Okay, we are now ready to find the dual. Now to find the dual, one more thing which you need to take care over here is the last two equations. Last two equations, because they originated from the same equation, they have the same coefficients. Of course, negative, positive. Okay, same coefficients with opposite signs, of course. So when you have such a question, you will not have actually four different variables. You will have three different variables. The fourth one, we'll use the unrestricted ones. I'll explain this with the help of this example itself. Let's understand. So I hope you can see that there are four constraints of four variables and three variables, so there'll be three constraints. Okay, the vice versa. So we'll start with the dual here. Step number one, the minimization will become maximize. So I'll have to maximize W, which is going to be equal to the RHS. Okay, so -3y1 plus 5y2. And as I said, plus 2 and minus 2 will contribute together. So we'll have 2y3 prime and -2y3 double prime. If you remember, we have used these notations for the unrestricted variables. Okay, so the same is going to happen here. Let's find the constraints. There'll be three constraints because there were three variables in the primal. So subject to, first one comes from all the x1s. So -2 y1, positive y2, negative y3 prime and positive y3 double prime. Because this is maximized less than or equal to the coefficient of x1, which is 0. You can just note -2, +1, -1, +1, and less than or equal to 0. Okay. Then comes all the coefficient of x2. So -y1, +2y2, +y3 prime, and -y3 double prime less than or equal to, again, x2 coefficient, which is 1 here. And lastly, we have 0y1 plus 6y2 plus 2y3 prime and 2y3 double prime, which is less than or equal to 3. Okay. So these are the three constraints, and we'll write here y1, y2, y3 prime, and y3 double prime. All of these are greater than or equal to 0. We will now replace y3 as y3 prime and y3, the difference between these two. Okay. So my dual now becomes maximize W is equal to -3y1 positive 5y2, 2 times y3, subject to -2y1 positive y2, negative y3 less than or equal to 0. Constraint number 2 will become -y1, 2y2 plus y3 less than or equal to 1, and the last constraint becomes 0y1, 6y2, 2y3 less than or equal to 3, and you will have y1, y2, y1 and y2 greater than or equal to 0, and in this case y3 will be unrestricted. We have seen how to deal with unrestricted to y3 prime and y3 double prime. We are going to reverse now. Okay. I hope this example was clear to everyone. There were two things which we managed over here. One was a less than or equal to sign, which was easy to handle. Okay, in the constraint one. Then there was an equal to sign, which split up into two equations and changing the signs and bringing in a prime and double prime and then the unrestricted variable. So this is a longer question which can come for 5 marks. Okay. So this will require a little practice and little being alert. Otherwise, the dual finding is a easy process. Fine. I'll take one last example and yeah, that will be it for the finding of the dual. Okay. So let's look at example number 3. The main question again remains the same. We are expected to find the dual. The question is to minimize z, which is equal to 3x1 minus 2x2 plus x3, subject to 2x1 negative 3x2 positive x3 is less than or equal to 5, 4x1 minus 2x2 is greater than or equal to 9, negative 8x1 plus 4x2 plus 3x3 is equal to 8, where x1, x2 are greater than or equal to 0 and x3 is unrestricted. So three things to take care of over here, because the question is minimize type. This is a problem, this is a problem, and this is a problem, right? So these are the three things which we will look into. That is, we'll multiply constraint number 1 with negative 1. Constraint number 3, we will have to split them up into positive, greater than or equal to and less than or equal to. And constraint number like x3 is unrestricted. This x3 is unrestricted. We will have to bring in x3 prime and x3 double prime. Okay, fine. So that's how we are going to work over here. And this will be the last example in this particular category. Fine. So we'll first write down the standard form. So we write down minimize z is equal to 3x1 minus 2x2 plus. This will be replaced by x3 prime minus x3 double prime, where we are assuming x3 to be x3 prime minus x3 double prime, where both x3 prime and x3 double prime are greater than or equal to 0. We would subject this to first equation to be multiplied with negative for the less than or equal to condition. So negative 2x1 plus 3x2 negative x3, which gets replaced by x3 prime, and this will become positive, greater than or equal to negative 5. Okay. Then 4x1 negative 2x2 plus 0x3 prime, negative or positive, whichever, 0x3 double prime, greater than or equal to 9. Here, this will split into two equations. One would be greater than or equal to 8. One would be less than or equal to 8. For greater than or equal to 8, we leave the signs as it is. x3 prime, negative 3x3 double prime, greater than or equal to 8. For less than or equal to, we'll have to change the signs. So 8x1, negative 4x2, negative 3x3 prime, and positive 3x3 double prime, greater than or equal to negative 8. Because we've changed the sign for 8 will also change. Okay. Now you can see there are 4 constraints. But again, the last two constraints have the same coefficients except for the opposite signs. So there we'll have y3 prime and y3 double prime. and otherwise we'll have y1, y2. Okay, everything else remains the same. So let's find the dual. So what's the dual given by? We'll have maximize, z is equal to, we'll take the RHS, that's negative 5, 9, 8 and negative 8. So negative 5y1, positive 9y2, 8y3 prime and 8y3 double prime. Subject to, we'll take the coefficients of x1, 1, 2, 3 and 4 coefficients, and they'll be less than or equal to 3 because it's a question of maximize. They'll be less than or equal to 3. So negative 2y1, positive 4y2, negative 8y3 prime, positive 8y3 double prime, and because of maximize, this will be less than or equal to coefficient of x1 from the objective function, that's 3. Next, we'll take the coefficients of x2, which is 3, negative 2, 4, and negative 4. So 3y1, negative 2y2, plus 4y3 prime, and y3 prime, negative 4y3 double prime. Again, less than or equal to negative 2. Then we'll continue further with negative 1, y1, plus 0, y2, 3 times y3 prime, negative 3 times y3 double prime. I'm not highlighting the numbers now, less than or equal to 1. The last one, we'll have y1, 0, y2, negative 3y3 prime and positive 3y3 double prime. Again, less than or equal to negative 1. If you remember, okay, we first write down y1, y2, y3 prime, and y3 double prime. All of them are greater than or equal to 0. Like the last sum again, y3 prime minus y3 double prime will be replaced by y3, okay, where y3 will become unrestricted. So let y3 is equal to y3 prime minus y3 double prime. So my dual becomes maximize, z is equal to negative 5y1 plus 9y2 plus 8 times y3, subject to the conditions, negative 2y1, positive 4y2, and negative 8y3 less than or equal to 3. Then you have 3y1, negative 2y2, 4y3 less than or equal to negative 2, negative y1, 0y2, 3y3 less than or equal to 1, and lastly y1, 0y2, negative 3y3 less than or equal to minus. Okay, so these are your possible answers. Okay, and for this, we can still combine it further. Why and how? Let's observe. These two again still have the same coefficients. So we will have to merge it as, let me copy down the other. Let me quickly just copy paste. Okay. So these two conditions, no changes. The last two conditions, because the variables are exactly the same. Okay, the y2 went missing. Okay. Conditions are exactly same except for the signs being opposite. So what we're going to do, we'll merge the signs, that is negative y1 plus 0 y2, I may skip, and 3 y3 is equal to 1. Correct? Because equal to 1 is what we were splitting into greater than or equal to 1 and less than or equal to 1. And then we used to change the signs and get this. So this is your final answer with y1, y2 greater than or equal to 0, and y3 is unrestricted. I hope the different dual questions are clear with everyone. So these are different types of duals. Of course, you can practice few more questions, at least one or two questions on your own to understand the technique properly. Okay, so this completes the sums on converting the primal to the dual. A question of this category asks for 5 marks in the exam.